Okay, now I'm going to introduce you chain rule and product rule. Okay, and first let me do some examples. Say if someone asks me to do question like y equals to bracket x x squared plus x cube, okay, and bracket power of 10. Okay, the way to do it, in your book, in the textbook, it says I have to use chain rule. Okay, but actually the only rule I need to know is this one. Okay, so what happens is, well, when I differentiate x power of n, I would have, okay, n times x power of n minus 1. So I do the same thing there. First, okay, I move the power 10 to the front, okay, and leave it minus 1. Okay, and okay, I show you. I will have 10 times bracket x squared plus x3 bracket power of 9. Okay, whatever in the bracket doesn't change, and times the differentiation inside the bracket, which is bracket 2x plus 3x squared. Okay, this is how it's done, and I rewrite it. I would have 10 times 2x plus 3x squared bracket, and another bracket x squared plus x cube bracket power of 9. Okay, the idea is to use this formula. Firstly, whatever in the bracket doesn't change, but we have to times the differentiation of whatever in the bracket. Okay, okay. This is basically your chain rule, the method of times follow whatever initially follow a simple rule, and times whatever in the bracket. Okay, and in your textbook they write confusing math symbols and formulas to show you that. Okay, what's happening in math, you okay, just remember to do this question this way. It's a lot easier to go with your chain rule as what the textbook says. Okay, I do another example to show you. Okay, so okay, assume I have a question like this: y equals to, okay, um, okay, x squared plus 2x, okay, square root. Okay. So I have a question like square root of bracket x squared plus 2x bracket. Okay, the idea to do it is to use this formula again, right, but convert it in this form: square bracket x squared plus 2x power of half, okay, and the differentiation of it will be, we move the power to the front, and the power have to takes away 1, and I have the times whatever inside the differentiation of whatever inside the bracket. Okay, so I would have half, okay, bracket x squared plus 2x initially whatever in the bracket doesn't change. Okay, and times the differentiation of whatever in the bracket, which is bracket 2x plus 2. Then I would have half bracket 2x plus 2, okay, times square root of x squared plus 2x. Okay, and this is my answer. Okay, now let me do one more examples. Okay, okay. Say if I have a question y equals to, okay, okay, let's do it like that. 16 on bracket x squared plus 1, okay, power of 10. What I do is I try to rewrite it first. I would have 16 times bracket x squared plus 1, okay, power of minus 10. We learned how to convert it in exponential in the tutorial of exponential graphs. Okay, so the differentiation dy dx, okay, will be, I leave the constant out, okay, times minus 10, which is the power, okay, bracket x squared plus 1, and minus 11, minus 10, minus 11, okay, follow this rule there, okay, times whatever in the bracket, the differentiation of whatever in the bracket, which is 2x, yeah, 2x, okay, and I can rewrite it. I would have minus 320 x, okay, on bracket x squared plus 1 power of 11. Okay, this is basically your chain rule, and in your book your chain rule is written as, okay, dy dx equals to dy du times du dx, okay, because du can cancel out, so they are the same. Okay, if you understand what they say in your textbook, then it's fine. If you don't, it's also alright. You don't actually need to understand this thing in math method. You only need to know how to use it, and this is a simple way to use your chain rule without substituting all the equations. Okay, and now I'm going to do a product rule. Okay, okay, similar to chain rule. Okay, in your book there, in your textbook there is well, there is a complex mathematical formula to explain what product rule is. However, it's quite simple if you don't, well, you don't have to remember the rule, or the formula. Just learn how to solve a question like this. For instance, if I have y equals to bracket x plus 10 power of 20 times bracket 2x, okay, 2x plus 1. Okay, the idea is the differentiation of this function will be we okay because we okay, we leave we have two variables in there, x plus 10 and 2x plus y. Oh, sorry, 2x plus 1. Okay, I state them as two variables, and okay, okay, and the idea is to keep the first variable constant, okay, x plus 10 power of 20, and times the differentiation of the second variable, which is 2, okay, and plus we keep the second variable constant, okay, and times the differentiation of the first variable, which is 20 bracket x plus 10 and power of 19 times